Hi, everybody. Thank you for joining us this afternoon. I'm kicking off the ITE committee presentations for today. I know it's getting a little late for some, but we'll try and keep it entertaining. So starting off with talking about one of our newer ones, the design guidelines for ITE equipment and immersion. Based on the number of questions I've heard today, hopefully this will drive even more questions and more participation with the work groups that's just now kicking off. So as we go in, first I wanted to talk about kind of the origins of the guidelines. There actually is equipment guidelines published. It was published back in December of 2020, so almost 4 years old. Some people in this room helped participate in those original guidelines, and it was a good foundational work. But since then, over the last 4 years, there's been a lot of industry changes. We also have a much larger community than we did back then. There's a much wider adoption of immersion cooling in general. And one of the key focuses is also the silicon that's available today. That's been a big topic, whether we're talking about force flow, targeted flow, how do we get past 400 watts a chip, how do we get past 1,000 watts per piece of silicon. Those of us in the industry know 1,500 watt plus is coming pretty soon as well. So how do we address those requirements and those needs? Also, more and more customers are looking for a degree of standardization and interoperability. It's been a little bit Wild West out there when it comes to form factors, both form factors for solutions like tanks, as well as form factors of servers. It's very common to have 19-inch rack mount servers converted. There are some more open rack type form factors. There have been proprietary form factors. So customers really want to be able to use their infrastructure for more than one generation and more than one product. So it really does require some degree of standardization and interoperability, as we move forward. So with that, we are doing a major refresh to the design guidelines. I said the committees are forming now. We do have, if you wanted to see the original specification, we do have a QR code there that'll take you right to it. You can also find it on the wikis and everything else, but this is what we're looking at doing a major update for. So what types of things are we going to cover in the new guidelines? Well, of course, one of the fundamental things are form factors. So mentioned, 19-inch rack mount is still common. There's a lot of tanks, a lot of solutions that standardize on kind of a 19-inch rack mount form factor because those are the most prevalent servers, available today. But more and more, ORv3 or Open Rack v3 is becoming popular. You've seen presentations on that today, both on the solution side and a little bit on the server side. And why the standard wasn't made specifically for immersion, it has a lot of features in it that are really nice for immersion, such as bus bars at the bottom, connectivity on the top. But we still want to make sure things are done in a manner that is applicable to immersion as opposed to cold plates, as opposed to air-cooled, things like that. There's also, the concept of immersion native servers versus immersion conversion. So immersion native, meaning this was never designed to run in air. It's probably never designed to run with a cold plate. It's a pure immersion design. And how would that differ from an immersion conversion? Because we are in this period right now where most servers are not designed for immersion and need to be converted for economies of scale. So along with that is there's a lot of confusion when it comes to terms around the types of immersion cooling. Whether we're talking natural convection, what's the difference between natural convection, direct convection? You hear forced convection, targeted convection, there's two-phase. So what do each of these terms actually mean? What terms should we be using as an industry when we're talking about solutions? And natural convection is fairly easy to understand, but when we talk direct convection, what exactly does that mean? There's some generic ideas, but are there specific flow rates required? Are there specific ways the fluid has to enter and leave? And as we get into forced convection and targeting, these are really exciting pieces right now, but everybody's got a different way to do it. So how do we make sure that everything works together and is actually built on standards? Then we also get into how are thermals tested? How is signal integrity tested? What about regulatory compliance? Regulatory compliance is something that a lot of us have kind of liked to close our eyes and stick our fingers in our ear and say, well, it works. But regulatory compliance is very important as the adoption of IT equipment in immersion grows. A lot of big companies, big data centers, they're looking for that regulatory compliance and need to make sure that what we are doing to servers falls within all the different regulatory bodies and that we're not violating standards that could lead to either safety issues or emissions issues, things like that. Connectivity is another big concern when it comes especially to networking and power. So how do we make sure that the different types of connectivity using, so think cables, how are we making sure that they work properly in immersion? How are we making sure that the materials they're made out of are the correct materials, that signal integrity is correct, that we're not getting fluid in places that we don't want fluid. And after regulatory compliance, service and support. People want to know how they're going to service and support equipment when it's deployed in immersion. It's what equipment is needed, what cleaning agents, everything else, because a server is going to go in, hopefully it stays in the tank for a very long time, but eventually it's got to come out. Either a component has to be replaced or it's the end of life of that equipment, and we want to deploy something else instead. So I did want to spend just a little bit of time on specifically what's not covered. And when I say not covered, that doesn't mean it's not covered in the cooling environments immersion committees. It means it's not specifically covered in design guidelines. Could very well get referenced in design guidelines, but we have a lot of committees and work streams that are very ably handling material compatibility, material reliability, fluid specifications, cleaning and safe handling. So while these are things that will be likely referenced in design guidelines, it's not something we're looking to tackle in the design guidelines work group because it's being handled by other work groups and other committees now. So why are these design guidelines important? Well, as we said, customers want to be able to utilize multiple vendor ITE equipment. They don't want one server manufacturer and that's all they can deploy, and then all of a sudden when it's time for a next generation or they want to change to another manufacturer, they figure out that the solution they have is not compatible with it. Whether that be compatible from a fluid perspective, as you saw some of the thermals that Andy was doing earlier on fluids, or whether it's compatible from a physical perspective. Hey, I changed form factors, whether it's compatible from a power perspective. So we see it quite a bit that customers want to be able to support multiple generations and multiple vendors in the same infrastructure. The technology also requires context and the terminology requires context and standardization. As we said, what do all these terms mean? I see a lot of terms all the time. I think I know what they mean, but it's very hard to find them written down. And it says, this is exactly what it means when I say natural convection. This is exactly what it means with direct convection. This is what force flow means. They're somewhat intuitive, but there's a lot of other terms that come up as well that we really need to all kind of be on the same page when we use them. We also need some more commonization for installing and removing equipment. You saw earlier today when we were looking at things like power shelves, hey, handles are needed. Yes, but where should the handles be? How far should they be above the fluid? What type of equipment do you need for hoisting it out? Because you really don't want to have a different kind of hoist or a different kind of clip or a different kind of mount to pull out one piece of equipment in a tank and then have something next to it that you didn't have to reconfigure your servicing hardware to pull it out. So, and because everybody can kind of do their own thing now, there really isn't a standard. Some might have bigger holes, some might have smaller holes, some might be above the fluid, some might be below the fluid. So it's another area to really focus on from the serviceability standpoint. And when we really get into it, it's knowing what ITE equipment works in which solutions. It's about what are your fluid requirements. So when you're making a piece of IT equipment, what was it designed to work with? Is this natural convection? Is this direct convection? Is this forced convection? What kind of flow rates do you need? What kind of viscosities do you need to make that work? Because as you've seen, it's not all completely interoperable. A basic CPU server is going to have different requirements than a high-end GPU server. we get back to what kind of equipment is needed, on site for that installation. We were talking about lifting and mounting, but there's other things you need for, how do you handle the little bit of oil spills? What type of PPE, might you need for servicing the piece of equipment? What do you need on site? What do you need in that spares kit when you're servicing thing? And most importantly, how can functionality be ensured? About to talk a bit about signal integrity, but how are we testing for signal integrity at the server level? How are we making sure that everything works and that we're not dropping packets and our PCI Express buses are all working fine to all of our devices, and that we perform equal or better than counterpart servers that would be used, for example, with cold plates or in air. We talked a little bit about regulatory environments before, but I put some of the main ones up here. I can tell you, most of what I see is regulatory is a little bit ignored. And it's not ignored because we don't care about it. It's ignored because there's a lot of open questions. So we are looking at having several of the regulatory folks from both UL and NIMCO involved. Regulatory certifications take a lot longer than technology innovation. So it's how do we get them on board, and we're all doing best practices to make sure when this equipment is deployed, it's deployed in a safe environment, and that everybody can get insurance, and that the fire marshal is happy. So when we talk about the best practices covered, a lot of things, these are things that have come up, all today, but heatsink and boiling enhancer design, how are we optimizing them? How are we on the same page for what works best in immersion? Compatible thermal interface materials. For those of you who've been in here, you've already heard this once or twice today. I can tell you, in a high-end GPU system, there's over 100 pieces of thermal interface material. Over 100. Every one has to be analyzed and potentially changed to make that high-end, hyper-converged GPU server work correctly. How do we handle, on the conversion side, detrashing in an environmentally friendly context for things like heat sinks and old fans and plastics and things that you just don't need, in an immersion server? Something a lot of people don't think about, adhesives and labels. For those who have worked with immersion for a long time, there's a lot of labels and stuff that peel off over time if you don't change them, if you don't coat them properly. This is not something customers want, a bunch of labels floating around and clogging up things, in their solutions. I know some questions came up earlier on optimal component placement. You don't want to put things in a immersion solution just any way. Some components are hotter, some components are colder, some components need more flow. So the proper orientation of how those components get put into the piece of IT equipment so that it's properly installed, in a tank are all very important. We talked about compatible copper and optical cabling. You can't just use any cable in a lot of the immersion solutions. So it is important that there is proper selection of things that are fluid compatible, both from a material standpoint, but also signal integrity. We do need to get to the standards for performance and reliability testing. Everyone kind of does their own thing now. There's a lot of good tools, especially from the silicon manufacturers, from Intel, from AMD, from NVIDIA, and we need to make sure we're using the right tools. The same tools you would expect an OEM or an ODM to use when they're doing a motherboard design are the tools we need to be using in immersion to make sure that those designs meet the same standards. And last, service and support guidelines. So how is this being handled? So some of the common challenges we address, form factors, of course. We're talking a lot about ORv3, flow rates. That's going to be, like I said, very important for IT equipment. What's the fluid? What's the flow rate? What's required? And lastly, that testing methodology. So I did put up a couple pictures just on some flow rate curves for things like Intel's targeted flow heatsink, but also what you have there on the bottom are the actual PCI Express I/O margin testing from an Intel tool. That's actually in fluid. By the way, being on the right side of the red line is good, not bad. But so making sure we're using those same tools across the board and across the industry to make sure these solutions are reliable in immersion. So lastly, my call to action, I said this is a new work stream just starting up. It's actually a retread of an old work stream, but we really need your participation. If you're in this industry, if you're involved in IT equipment, we want to make sure we have as much feedback and as much participation as we can get. So I ask you to join either the ITE committee, which is kind of over all of this, or specifically the design guidelines for ITE, because we do want participation from OEMs, ODMs, fluid providers, tank manufacturers, everybody who's involved for how ITE equipment should be put into servers and serviced. I know I just ran out of time, but if anybody has any questions, I will be around the rest of today. Please find me. Thank you.